All right, now the next one's asking us to use Euler's formula. Now, just like any other formula, I'm going to ask you to write it down first and just fill in the pieces that are missing. So remember, Euler's formula works only for polyhedrons, and so we're going to be looking for the missing sides, or the missing vertices, or the missing edges, the number for that polyhedron. So the very first one, we write our formula down. So the vertices minus the edges plus the faces equal 2, and we just plug it in. We got 5 minus the edges. I don't know what those are. You can call it X or E. I just actually put an E in there this time. I think in class I put an X in for some reason. Plus the number of faces, which is 5, is equal to 2. Now here you got to remember to combine like terms. Don't get lost with your signs here. But I should get 10 minus E is equal to 2. Subtract 10 from both sides. A negative E is equal to a negative 8. Divide both sides by a negative 1. Our number of edges is 8. So it's 8 edges. Not hard to do. Now the next one we're going to have, it's going to be faces, and I'm going to call this one X this time instead of F, but you could put an F in there. My formula for Euler's formula stays the same. The vertices are 6, the edges are 9, the faces are X, and they equal 2. Combine like terms, I get a negative 3 plus X is equal to 2. Now to get rid of that negative 3, remember to move it to the other side, we add with a positive 3. So we get X is equal to 5. So that's 5 faces. So that polyhedron would have 5 faces, but it also has 9 edges and 6 vertices. Kind of curious what type of figure that would be like. So it's kind of cool. I think it'd actually be the triangular prism like what we just saw up ahead. So I think it's actually D is what that one is. All right, now let's look at the last ones here. Our vertices minus edges plus faces equal 2. Again, I'm going to put an X in for my missing one, which is my vertices. So I got X minus 18 plus 8 is equal to 2. Well, negative 18 plus a positive 8 is a negative 10, so X minus 10 is equal to 2. I'm just going to add 10. X is equal to 12. So we have 12 vertices. All right, now the next part is what's called a net. A net is just a two-dimensional diagram of a three-dimensional shape, okay? Basically, if you fold it, it would make that shape. So our edges kind of turn like creases, and that we put it all together. If you want, come talk to me. I have a document I can send you that has links to different nets, and it gives you visuals of what those nets are, and they're really helpful. So nets should be able to tell you what type of figure that you're making from them. So let's look at the ones down below here. If I was to take this, now imagine that these are all on hinges, okay? And that I can bend these up. If I bend this one up, what do I end up making? Yeah, I end up making a cube, or a rectangular prism in this case. Now if I was to bend this one, and I put together, you realize, oh, that's going to be at a center point. If I have a circular base, that's just one thing, and I know the sector is going to be there, I'm actually going to have what we have here as a cool cone. So that one's a cone. C and D had moved up, but it's on the other side. So let's go to the other side here. Here's C, here's D. Now, looking at this one, remember my edges right here turn to where I fold. So if I fold those up, they form a really cool, because these all come to the point, would be a pyramid. It's a triangular pyramid, and you need to be as specific as possible by naming the base. And on the next one, if I put these together, I'd make a cylinder, and probably a right cylinder at that. So it's very easy to pick these out, but if you're a problem seeing that, my biggest thing is do what it does here, okay? Literally trace it, cut it out, and fold it together. See what shape you get. It's the way that you make it work. And the next thing is called, that we're going to talk about, is a cross section, okay? A cross section is a two-dimensional, it's when a plane intersects something and like cuts it in half. Like if I have this sphere and I cut it in half, like I'm sitting there sawing it down the middle, and I open it up, my two-dimensional cross section ends up being a circle. So a cross section is what you get, is the two-dimensional figure you get when you slice it through. So it's kind of like when you're slicing a loaf of bread. Because when you have a loaf of bread, when you're slicing it, you get the cross section, and that's just the same like the piece before. That's a two-dimensional slice of bread is what you're really thinking of. So it's a cross section. Now, the cool thing is with cones are the huge cross sections that you use. You use them a lot in algebra too. But if I was to sit there and have a cone and all I did was slice it right at the tip, you'd only have a cross section of a point. Now, if I have here a pentagonal pyramid and I do a cross section and I slice it, look at my two-dimensional shape right there. It's a pentagon. Here I have hexagonal. Oh, finally found my hexagonal prism. Couldn't find it earlier today. Here's my hexagonal prism. It really basically, it's being folded like this. It's coming out at you. If I was to cut this right through, slicing it, what would be my cross section have to be? Yeah, it's going to be right there. You can see it being formed. A hexagon. So our hexagon would have to have that. And then if you notice, if I went through the cone, if I was going straight here and just slicing it through down, you'd also end up getting a triangle. The cross sections are going to be two-dimensional pieces, okay? It's like, what do you get if you'd open it up? All right, and last but not least, we have to figure out how to work with, and this one makes me laugh, cheese, okay? It's a horrible example. I apologize for putting it on here, but it was there. It came to me. It says you're given a piece of cheese that's in the shape of an equilateral triangular base, okay? So here is my prism. Now, I know it's not great, but here's a better example of this. It should look something like this. And the first thing they want to know is how can you slice the cheese to make an equilateral triangle? So how can I slice it so all the slices look like equilateral triangles? Well, the key thing is, notice how I just did that. I did it so I was slicing parallel to the bases so I get that triangle. So how would you do it to make an equilateral triangle? Slice parallel to the bases. Now, how would I get a rectangle? Well, you go the long way. Because the cool thing is, no matter what, if I slice this way, if I opened it up, you would see a rectangle shape. So for a rectangle, you slice perpendicular to the bases. So hopefully that kind of gives you an idea of how to work with these. Your homework is just the worksheet. Use your notes, have it close to you. Just a few things I want to remind you. When you name a pyramid or a prism, always know what your base is, and just give me as specific as you possibly can.